Now I'm going to need everybody to not be mad at me for a second here in The Farmer Was Replaced. First of all, congratulations, you got 1,000 likes in like 6 hours or something like that. I should really up it, but I'll continue to do 1,000. You know the drill, okay? Here's what happened in off-camera land. I did a little bit of code refactoring, okay? Did a little bit of movement of things around just to make our lives a little bit easier. And the big main thing is that every function that is every crop is now its own function. Okay, so we've got plant grass, we've got plant carrots, we have plant trees, and we have plant pumpkins. All of them nice and happy existing. Okay, that allows us to build a main function now, and I've just got our main function over here. It's not really a function even, but it is basically going to be where I kick off my code. So I can just kind of run it, right? And it makes it very simple for us to do things. If I want, I can loop this infinitely, right? So I could do something like while true, do all of these, and then like requirements plus equals another 1,000, right? And this will run infinitely forever until I stop it. So we're effectively idle mode here, which is cool, is dandy. You would think that we would be coming into today, like I said we were going to, and we would unlock sunflowers. I'm not going to do that, okay? I'm not going to do that. And here's why. I was sitting and I was thinking while I was refactoring this, and then I was thinking while I was making dinner, and then I was thinking while I was eating dinner, and then I was thinking while I was laying in bed, because games like this just take over your brain a little bit. And I was thinking about how we can completely rewrite, well, we can't completely rewrite it, but we can completely improve the plant pumpkins function. And it actually requires us completely refactoring this function right here. Let's talk a little bit about it, okay? So if you did not see last episode, or at least don't know what the heck we did in the last episode with pumpkins, let me show you pumpkins real quick, okay? I'm just gonna up this to 5,000. Or you know what, let's do 4,200 so that we can get some pumpkins on the board here. And then we're going to take a really close look at how this runs, okay? So the pumpkins come in. If there are spots that die, it scans back and it fills in those spots that scanned. And then it has to scan all again, and then it pops it, okay? And then it scans again, and then it goes again, right? And it's just going to keep on doing this. Is it bad? No, and a lot of you said, you're like, Tyler, that's pretty efficient, like, which I was surprised about, because I immediately found where the inefficiencies lie. Obviously, this is horrible, having it to scan the entire thing. So, here's what I thought about, and what I have theory crafted, and I'm prepared to code today, is what if we could tell the drone to go to each one of these spots, right? That are not currently filled with a pumpkin. What if we had a way to keep track of those positions and then force the drone to go back to them and fill them in with pumpkins, and then check again? Did you fill those in with pumpkins, and go back to each one of them and then check again if it has to refill until all of the spots are filled, and then harvest, right? You may go, Tyler, impossible. I'm going to prove you wrong today. So the first thing that we need, and it's hilarious because I didn't think at all about this, but we unlocked utilities, right? And I went, why in the world would we ever need the min, max, and absolute value function? Let me tell you, we're going to use absolute value today. And then the pumpkins go directly into lists and fertilizer. I ain't worried about fertilizer, but lists are very, very valuable, man. This is like the heart of Python programming, is a list. A dictionary is also the heart of Python programming, but a list is, God, this is the good stuff right here. So for those that don't know what a list is, it's basically a two-dimensional array. And if that makes less sense to you, it's a list. It's a list of items, okay? A list of anything. So we can just dump values into a list. The number 2, the value true, items.hey, different entities, and then we can access those pieces of the list by just plucking out the list at the 0 position, the list at the 1 position, the list at the 2 position, things like that. We can also iterate through the list using a for loop, all things you're going to see me do right now. We can also append to a list. This adds an element to the end of it. We can remove, which removes it from the list. We can insert them at a certain point. We can pop off a certain point and return it. There's a lot of things we can do. We can get the length of a list. So we're going to utilize lists today to essentially, here's how the code's going to work. We're going to loop through the pumpkins and plant everything on the first go, okay? If they all succeed, that's great, we'll harvest, right? But if they don't all succeed, and we're going to most likely see that they don't all succeed, we're going to have to scan the grid again after we plant for the first time, and we're going to have to look for all the spots that don't succeed, right? So in this case, we know that this spot right here is at 1 length of the grid, right? Which in this case is 5, even though it's technically 6, right? Because this is the 0 position, so this would be at 1 5. Okay, sorry, brain broke for a second. This spot would be at 1 4, and we can dynamically code this when we get into the movement to be the length of our world size, right? So we would have 1 5, we have 1 4, we have 2 2, we have 3 1. We have 4 1, we have 4 2, we have 5 1, and we have 5 2. And we can build those as basically coordinate pairs inside of a data structure. And then we can use those data pairs and basically create a function that says, hey, go to that location. Okay? Now you're going to ask, how do you build a go to function? Let me tell you right now, we kind of already did. Okay? It's inefficient. And it's only doing a go to 1 position. And that 1 position is we want to go to 0 5, right? Which is currently our world size. We want to go to the top left, right? We need to remake this function to be able to take any coordinate pair in, right? We can still keep the reset drone because we use it in a lot of places. It's easy, right? It's something we can define a lot, but we also want to make it where we can just do go to 0 0 and it can go to 0 0. Now, it's relatively simple if we want to do this inefficiently, but I want to make this interesting today, and thus I have built just a horrific algorithm, and I literally wrote it down on a sheet of paper because I was thinking about it, and it took up 2 whole post-it notes for my algorithm, so it might not be right, okay? I made it up myself. This is a pretty peculiar scenario to make this efficient, and it's actually so peculiar that I'm going to need to pull up MS Paint to actually map this out and show you it for it to make more sense. So we may spend more time in this episode in MS Paint than we will actually in the game coding, but it's fine, okay? So we want to go to some coordinate pair, okay? So we're going to define a new function. We're just going to call it goTo, and that coordinate pair is going to be xy, okay? Now we're going to go into MS Paint, okay? So you can see my nice little grid here, and we know for a fact that 0 0 is down here in the bottom, and over here is 5 5. Now, there's other coordinates that we probably care about in here. For the purposes of some testing for us, I would like to add the entire bottom row, okay? And then I also want to add an entire column. It doesn't matter which column, but having an entire column is useful, so we'll use the 2s, right? And this is literally just coordinate pairs of the grid. Nothing crazy, right? Absolutely nothing crazy. So you may remember, if you've ever taken a math course before, that you can calculate the distance between 2 points, right? If I wanted to get the distance between 2 5 and 5 5, there's a formula. You do x minus x, which would be 5 minus 2, and then that is something with the y's, and then it comes out that this ends up being 3, right? Because that's the distance between 5 and 5, 5. In our case, we're not going to think of it, I mean, we're kind of doing that, but we're going to think of it a little bit differently. And the reason we have to think of it differently is we can wrap around the grid, right? Like for us to get from 0, 0 to 5, 0, it's not a distance of 5, okay? It's a distance of 1 because we just need to go around the grid, right? This is an arrow that loops us back over to here. And that makes this formula a lot harder to make because it's not just calculating a distance and working with it. We have to build something that can tackle that distance. So here's what I came up with. And in order for us to use it, we have to understand absolute value, okay? Absolute value. Now, if you're like me, you probably learned absolute value in like, I don't know, 8th grade, and then used it in a couple of algebra statements in high school where they said, hey, what's the absolute value of negative x? And you went, it's x, because anything that goes into the absolute value bars comes out the positive version of it. And if you're like me, you probably never used absolute value in your life until you potentially took a coding class and utilized it there for something similar to this, doing like a breadth first search or a Dijkstra's algorithm or something like that, for which I'm not using a breadth first search or Dijkstra's algorithm to solve this issue if you are a computer science person, aka a geek, such as myself. But I'm not going to do that here. I've made my own stupidity that I'm going to show you. But the value that absolute value provides is that it's a distance, right? If we wanted to get the distance between this point here, 2, 5, and this point here, 5, 5, we can do 2 minus 5, right? And the absolute value of that ends up being 3 still, even though this number is negative 3. So we can, distances can't be negative, right? It's a positive distance, which is why absolute value comes into play. But this being a negative number helps us to make determinations about which direction we are going to go, okay? So here's the disgusting formula that we need. It is the absolute value of basically our current position and then where we're going to's x and y. So we're going to need to define our current x, which we'll just call cur x, right? And this is get position x. So this is where we currently are. And then hilariously, curry ends up being our variable name here. Just very happy that it was not accidentally a slur. In this case, it's just funny Indian food. And I will pray that I don't accidentally do that in the future. So we would want to get our, if we're going to this position, these are our future x and y. These are our current x and y. So we're going to get the absolute value of our current x minus the x that we're going to. Then we are going to check if that is less than our world size, which is, we should actually just define world size because we're going to use it multiple times here. So get world size. We're going to call this our size, okay? So if this is less than size divided by 2, and in this case, that is also our current x minus x is less than 0, then we do something, okay? This is our statement. Now you're gonna look at this, oh, I'm not even showing you. Oh, it's gonna be the big reveal. Okay, here you go. Cur x, cur y, size, and then this big long statement. Sorry, I still had the paint up on the screen. That's my bad. You'll survive. Maybe I'll paste this over it in the video so that you can see what I was doing, okay? It works out fine. We're gonna have like 8 of these statements, okay? Because we need this for, it's going to be 4 different cases that can happen. You can have 2 less thans here, you can have 2 greater thans here, and then you can have a greater than here and a greater than here. These are the 4 potential cases that we can have for the x's. We then have to do this again for the y's, and there's certain movement that we're going to do whether or not these take place. And this is where we're going to take a look at our grid, and I can hopefully, it's a big hopefully, explain what my brain has come up with here, and hopefully it's accurate, because I haven't actually, I've ran some tests on sheets of paper, but this is the first time that I'm coming into the game, okay? So currently, let's take a look. Our drone is on position, this is 1, 5, okay? So our current position here is 1, 5, meaning that this current x is 1. I'll put this right here for right now. Our current x is 1, and our current y is 5, okay? So we are going to get the absolute value. Well, and let's say we're trying to go to, we'll say we're trying to go to this position right here, okay? So this is 4, 2, all right? So we want to go to 4, 2. So I guess this is actually where I'll put that. So now we would follow our function, right? We're going to get the absolute value of our current x minus our x. So we're going 1 minus 4, and this is going to be 3, okay? This right here turns into 3. Then we have our size divided by 2. Now currently our world size, if we were to run our debugger here, our current world size is 6, which makes sense. We're in a 6x6 grid. So 6 divided by 2, this is going to be 3 as well. I have managed to pick the one time where this is this doesn't work. Let's move you back to the beginning, okay? Let's make sure that you're at 0, 0. We will just do a reset drone here. Reset drone has not been defined. It's because I have errors in here. Okay, chill for a second. Just put in some passes. This is complex code, ladies and gentlemen. So we're in hell, like a little bit. Okay, so you're at 0, 0. So let's pretend you're 0, 0 instead. And then we will calculate this. So now the absolute value of our current x, which is 0, minus our x, which is 4, this is going to be a 4. So is 4 less than 3? The answer is no. So we're going to move past that if and into our next if, okay? And all of these are going to be elifs in here. Now we're going to look, is 4 less than 3? No. Is 4 less than 3? Yes. Okay. So that's cool. We know we're going to at least get part of this if block squared away. So then we'll enter into our second if block. Is our current x minus x less than 0? So our current x, which is 4, just kidding, is 0, because we're at 0, 0, is 0 minus 4 less than 0? And the answer is yes, because this is negative 4, okay? So we would be going into this block, and what we'll want to do is then, while current x is not equal to x, we are going to move. And where are we going to move? Well, let's think about this, right? Let's think about this. If we want to move from 0, 0 to 4, 2, what is the fastest way for us to move in the x direction to this location? It's going to be going west, not going east, because it's only 2 moves to go west, whereas it is 4 moves to go east. So in this case, we will move west, okay? Now you're going to sit there and you're going to go, Tyler, how in the hell did you figure this out, okay? It's pretty simple, all right? It's not, but it's kind of simple. You need to look at the grid in the way where we're always going to be like to the left or right of the middle line, right? So our absolute value, the distance that we are away from something, is going to change because of the looping. This all comes back to the looping, okay? If we were right next to something, then this size value is going to be very low, okay? The absolute value is going to be very low, and thus we can then know that if you're right next to it, we're either going to be moving 1 in either direction. And that's where now you can use this piece to determine should we be going -1, aka like to the left, or should we be going +1 to the right? I didn't explain that even remotely well in the slightest. I don't know how to explain. I know how to figure out the logic. It's really difficult to explain code logic to a YouTube audience, okay? But trust me on this. We need to add in basically these two inner statements are going west, okay? And then these two statements up here are going east. And if we change this and we come in and we do you are going east, and then I copy you and we put you here as well, this should account for moving our person the most efficient path possible to our X location. And we can kind of test this, okay? I'm gonna bring back up Paint, and I'm gonna not forget to move it away. And I'm also going to move this. We're gonna chop it to just the grid. I know that we have the grid like on the board here, but I think it's easier to be able to write on this. So if I wanted to move from 0, 5 here, or 0, 0, 5 to 4, 2, like we just said, we're going to, looking at our code, we're going to say absolute value of, well, I suppose we already did 0, 5, and 4, 2. So let's do a different one. Let's do 3, 4, and 2, 4. Okay, and this is actually a really good example here. So let's pretend that our current position is 2, 4. So we'll run through our logic in the script. Okay, our current position is 2, 4, and we want to go to 3, 4. So our absolute value of our current X, which is 2, minus our X, which is 3, that's a position of 1, is 1 less than our size divided by 2? Yes. And then is 2 minus 3 less than 0? The answer is yes, it is. So where are we going to move? We're going to move east. So we are going to go from 2, 4 over to 2, 3. And then we're good to go. But now you're going to say, Tyler, what if our starting position was 3, 4 and we needed to go to 2, 4? Well, let's swap that around, okay? And this is where the other use cases come in. This is why we have 4 conditionals for this. Because now, absolute value of our current X minus our X, it's still going to be 3 minus 2, which is a positive 1. That is still a size divided by 2. But now this fails because our current X, 3, minus our go-to X, which is 2 in this new case, less than 0? No, it isn't, okay? So now we move down to this one where it's greater than 0, and look at that. Now we're going left. Now we're going west. So instead of us moving east 1, if you do the reverse, you're going this way 1. And that's why you need 4 cases here. Because there's 4 different approaches that can end up happening, and this is all caused by the looping being a massive pain in the ass. Okay? If there was no looping, it's so much easier to figure this stuff out. But because of the looping, you need all this. You might not need all this, but this is how I figured it out. And I'm very proud of this because, I mean, it's kind of a wonky algorithm, man, and it's kind of strange, and it's kind of fun. So now we can bring in our y's into here, and we can basically just anywhere where there's an x, we're gonna replace it with a y, and then we'll have to change our directions here to, instead of being east and west, it's gonna be north and south, and I'm inevitably going to forget one of these values and it's going to screw everything up. But the hilarious part is that we probably won't even notice. Our damn drone is so fast that we're building all of these efficiencies into this. And it's really, we're never going to notice because he's so damn fast to begin with. So a lot of this was just like for fun. And your eyes have probably glazed over in this episode because now we're getting into like some really complex algorithms. I don't know why there's just a 4 chilling out over there and over here. Okay. This looks pretty good to me. This is north, south, south, north for the record. In case you, and if you want to, I'm telling you, take the damn paint window, just open up a grid and plot these out for yourself. And you will find so quickly that my math is accurate here. I think there may be like some fringe cases where it's not, but I'm pretty sure it's pretty good. Okay, so let's test it. If I wanted to now with our debugger, we want to move our drone. We can now call go to, let's send them to 4.2. Okay, so go to 4.2, and then it immediately just implodes. Okay, why did you implode? It's not a good sign. While current x is not equal to x. While our current x is not equal to x, move west. How are you stuck moving west forever? You should. You're a 4. Are you a string in here? Why is that in an infinite loop? What am I missing here? That's definitely an integer that I'm passing in. Can I when we do I have the type function available? I guess I don't. Does get position x and y return a string of the, I guess this is something that I now need to see. Get position x returns a number representing the current x coordinate. Okay, am I crazy? I don't think I'm crazy. What is our let's get position x. Have I had this wrong the whole time? Because I'm gonna be very sad if I have this wrong. Okay, current position is 1, and if we print our current y, we should get 1, 5. That makes sense. We're at 1, 5. Okay, and if we want to go to now 2 or 4, 2. Okay. Why did you not go to that spot? Now it's not moving at all. Well, what the heck have we done, man? Hold on. Go to 4.2. It didn't hit any of these now. Am I tripping? This should definitely work. This makes my grand reveal of this working a lot worse when it doesn't work, by the way. Because it's currently saying that none of these are active. But that's impossible, because it should hit one of them. Let's run the math, okay? If we're going to 4.2 and we're currently at 5.1, okay? So we're at 5.1. Can you sense the panic in my voice right now? So this will be a 5 and a 4 if our current x, which is 5, minus our x, which is 4, is less than size divided by 2, which it is, and our current x minus x is less than 0, which it's not. So we move to here. The absolute value of our current x minus x, which is 1, is less than size divided by 2, which it is, and current x minus x is greater than 0, which it is. You should enter into here, bro. Right? Like, oh, am I stupid? I'm stupid. I was running this instead of running this. So you're still getting trapped inside of here. So why do you go into this branch though? Our current x minus x is going to be 5 minus 4. 5 minus 4 is not greater than size divided by 2. Why are you getting in here? Can we just real quick run absolute value of get, let's print get position x minus 4. Because realistically, this should be a 1, man. And get rid of the go-to for right now. That's 0. What? Why is that 0? Oh, because we're at 4 right now? I mean, that's a good point. Can you not be at 0? Can we put you back to... I mean, I guess I want you... I just want to move you right now. Can you move east a bunch? And then just move east. Okay, so now you're on this... Is this where we wanted you to begin with? This is 5-1 now. So, position x is 1. I think I was getting screwed up because this is a 5. I might have been stupid this whole time. Yeah. Oh, we can't do this, man, because this never changes. Ha 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 ha. That's why we're in the infinite loop. I have to not do that. I have to get the position. I have to get the position in here. That will definitely make a very big difference, okay? It's just a little debugging, ladies and gentlemen. It's a little debugging. We can still keep our curry variable. It's very, very fun and nice. Now this is going to work like a damn charm. It's going to work so damn well. So when you move to 4-2, he will now... Come on. What's your problem? What's your problem? Oh, it's because we're missing our else branch. So our else branch... I obviously had this all taken care of. Our else branch is basically what happens if it's 0, right? Which is what's happening right now. It's going, hey, you're at... If we print out what this ends up being, well, what this ends up being, it's 0, okay? Which means, or it's not 0, it's the value of size. Size is equal to this, which is the one case that we don't have, okay? So this basically just becomes a what direction do we want to go, because it's equal on both sides. This is if you had, say, we're going from... We'll go down here because it's easy. You're going from 1, 0 to 4, 0. You can either go 1, 2, 3, or you can go 1, 2, 3. You get there in the same amount of moves when the grid is even, right? So in cases where we can get there in the same amount of moves, we'll just go a certain distance, okay? In this case, we'll go east and north will be our default for this. Now, if we go to 4-2, why? Why do you hate me? You're not at 2, bro. You're not at 2. It's because I changed this to an X instead of a Y. And now you're stuck in an infinite loop because we have the current position of X, not Y. He's at 4-2. Okay, now if we want to send him back to 0-5, we can send him back to 0-5. And he's going to take the fastest route. That was not the fastest route, though. Because he should have gone over 2 to the right. Right? Am I crazy? Maybe this has all been for naught. That goes you do the 2-5. Now if we change this to like 2-6... 2-6 doesn't exist. Ah, that's an interesting thing. I have to make sure that I don't do that, but that should never happen. 2-4, 2-3. This is good that he just steps down one by one, because that means that our algorithm is working just fine. Now if we switch it back to 2-5, he should loop. Brilliant. Okay. What if you go to like 4-5? He goes over 2. So now he's tracking, right? He's doing everything the way it needs to. We ran into no issues. Everything was fine. Everything was so great. It worked like a freaking charm. So now we can use this, okay? And we can use this in pumpkins. And we need to really rethink this over here right now. So, like I said earlier, we need to loop at least once. Okay, we need to loop once to plant all of our pumpkins. What I would like to do is I'd like to actually just reset. I'd like to reset grid to nothing right now. So if you can just harvest grid for me. Obviously not the most efficient harvest of our grid, but it gets the job done. And then you can reset drone. We can also, instead of reset drone, we can now call go to 00, and it's actually a more efficient, well, 00 is there, which makes sense, but now we can do go to 05, and he goes to that corner. But I still like the fact that we have reset drone, and I think that that's pretty cool. I feel like I was so excited about this, and then I like completely botched it. I was right there. I was right there the whole time. I just had a couple typos. It's the nature of coding live, man. It'll get you. It'll get you. Let's move. I want to move this down here, just so I can see my damn grid a little bit. So we're going to enter into the loop, okay? And we want to. Our check system is now not needed, so we do not need to go into our check system, but we are going to want to have some like flag variable that we are tracking as we go. In this case, I'm just going to set flag to true, and then while true, he's going to go, and eventually we're going to do a while. We're going to change flag to false inside of here, and then we'll harvest, and it'll work out fine. So he's going to enter into the loop, and he's going to do his first plant, okay? He's going to do his first plant. He's going to go all the way through. He's going to plant everything, okay? We might want to think about this a different way. We definitely don't need this anymore. If it is not a pumpkin, and this is some some jank ass code, bro. What the hell was I doing? Okay, so if all of those, then you plant your pumpkins. We want to, so this is our first loop. Once you're done with your loop, okay, this is where we're now going to enter. This is where we're going to enter into while flag, to be honest. Like, I want to, I'm going to create a new loop down here of while flag that now we're going to loop the grid again, okay? And as we loop the grid, we want to do a check of, and we also want to make sure that the very bottom of this loop has moved south, and the very top of this loop, meaning outside of this one, has moved east. And then what we want to do in here is we're going to be checking each spot. So if get entity type is not equal to entities.pumpkin, then we're going to track that. We're going to track that coordinate that we're currently at. So we're going to have a coordinate list here that is just going to be empty. And if our land that we are on is not equal to a pumpkin, then we are going to say, hey, chord list.append our current X position and our current Y position. Get position X, get position Y. And I'm actually just going to store those. Look, those of you that are coding experts, you're going to go, Tyler, you can use a tuple here. Frick tuples, I hate them. We're just going to put them in a list. It's fine, okay? It's completely fine. We're going to store those positions inside of a list, okay? Then what we're actually going to do is after this loop, we're actually going to say if chord list is not, I mean, you can actually just say if not chord list, then you're going to enter into this loop, okay, which includes this. And then the else here, so this is basically if the chord list is not empty, okay, then do your loop through, okay, and make sure that you grab all of the coordinates where stuff is, okay. Then you're going to, if the chord list is filled out, then we're going to say for each chord in our chord list, we are going to go to let's set up a while. We'll set up a while chord list here, actually. Then for each chord list in chord list, you're going to go to chord at 0, chord at 1. I've probably lost so many of you because I think I've lost myself at this point. And then you're going to check if get entity type is not equal to entities.pumpkin. Am I reinventing the wheel here? I might be reinventing the wheel here. Hold on. No, I think we're fine. If get entity type is not equal to entities.pumpkin, then you are going to, we're going to have a temp chord list, okay? We're going to have temp chord, which is going to be empty. We're going to assign temp chord with chord, and we're going to plant a pumpkin, okay? So we're checking everything, but we're doing it here too. But these are pretty simple because this first one needs to be, we're still scanning the entire map. But the second one is we're only doing our go-to position. So we need, these have to be somewhat similar in this regard. And then we will assign, the while chord list is kind of wacky here. I almost just want to create a while true, and then I'll break it when I need to. And then at the very end of this, we're going to say that chord list is now equal to temp chord. Okay. And if temp chord is empty, so if not temp chord, then we will harvest. And then we will break the loop. And that will put us back into while flag, which is actually just not needed at all. Because I never actually need a flag variable, because all of this should run as we go. So I can now bring these all in one. I understand that it looks a little wonky here. I should move these all out one, but this is, I believe, still valid Python code. And I think that this is all we need. Maybe? Let's double check. I could just run it and we can see, but I think this is all we need. So we're going to plant all the pumpkins, right? Easy peasy. And then it's going to, we're going to be back to the top, essentially. Then we're going to, first loop through is, oh no, I do need this on a, well, the first time through, maybe you don't even need this if statement, because we're going to loop once, okay? And then after looping once, then you enter into the infinite loop of our coordinates, right? This makes sense to me. So bring all of this out, all of this out. So we'll empty our chord list. We're going to loop through the entire range. If one of the spots is not equal to a pumpkin, put that coordinate in, plant a pumpkin. You're going to do that for the entire grid. Then you're going to hop into here. Temp chord gets assigned to nothing. And then for each chord that we documented here, we're going to go back there. We're going to check if it's a pumpkin. If it's not a pumpkin, we're going to append that new coordinate to temp chord, and we're going to plant a pumpkin, basically putting that back into the database to look at next time. And that's only if it's not a pumpkin. If it is a pumpkin, then we're not going to plant it, right? And then you're going to loop back up. You're going to do all those coordinates. When you're done, you're going to reset chord list to be temp chord. And then if temp chord is empty, we're going to harvest, meaning that there's nothing else to look at, and it should move better. He says should, okay. Let's try it. He does a quick scan because he harvests to begin with. And we're in hell. Okay, how did we get in hell? We got in hell because all of this is inside of this 4 block. We need to move all of this out here. I had it wrong. I had my indentation wrong. The curse of Python, ladies and gentlemen. If only I had brackets that I could use to determine my my location of my lines of code. We did not want that underneath this. That was the issue. And we also don't need our flag anymore. Okay, reset my grid, please. Harvest grid. And he will, I mean, every time we run him, he resets the top and harvest, so that's fine. So start planting. We do have a small issue that is technically in my replanting. Oh god. Okay. Okay, he's a little jacked up. He's a little jacked up. In our replanting, we need to make sure that we do this right now. But if you run out of seeds, man, we have to just reset everything. So that's fine. We'll do this down here. We'll make sure that we add our water me. That's basically just called like hard reset of everything at that point to do that. And that's fine. I mean, it's the price you pay a little bit, but this did get screwed up. And why did you get screwed up? Because these should be different. This should be moved in one. That's why you were screwed up. It's indentation, man. Like that's our biggest issue is indentation. Okay, go again. I have so much faith. I have so much faith. It's difficult to see a lot of this in action. I mean, I guess I could bring up the debug menu. How do I do that? I think it's in this. So, yeah, output. Brilliant. Tried to plant stuff, but there was something already there. What I want to do is I want to print out I want to right here, just to show you guys, this is more for your benefit than me, so you can see how I'm thinking about this. Our chord list here, and then I'm going to print out temp chord here. Temp chord and print. Sometimes this is janky as a text editor. Temp chord. And then we're going to just do a little chord list equals this, and temp chord equals that. Just to make it a little bit easier to see what's going on. And then I'll reset this for the 12,000th time. And we should now see these pop into the output once we get stuff going. And we can pause this to make sure that we're accurately seeing stuff. So now you're doing your next scan. You're adding stuff to our chord list. And there's our chord list, okay? So it's brilliant. These were all of the spots that didn't have a pumpkin on that last go through. So we should see, since this spot does not have a pumpkin, this should be a coordinate in this list. This is at 3, 2. And if we look in here at our coordinates, that is every friggin' coordinate in the list. If get entity is not equal to entities.pumpkin. Why is every coordinate in this list? I mean, that is quite literally every coordinate. What did we do wrong here? If get entity type is not equal, that's because get entity type I did not do as a function. Is that the issue? Is get entity type a function? I'm pretty sure it is. It almost has to be, right? I mean, we can look at this. Interesting that the game was fine with that. I just forgot the function on it. Get entity type, yeah. So we need to make sure. Weird that it was just completely fine with that. But that's okay. Make sure we add our functions in here. And then we try again. Okay, it's going to take a little debugging, but in the end, you're going to have a very efficient pumpkin code. Get ready for your output here. This is a good chunk of ones that are missing. So shortly, there's our list. That looks a lot better. So we should see 1, 3, and 1, 4. So 1, 3, 1, 4. I guess 1, 2 also may have, but it turned into a big pumpkin, so it's hard to see. Now we will see as we continue this. It's going to plant those 2. Our temp chord's filled out. And then it harvests because it went to all those positions, because it went to each one. And then it kicks off again. God, is it good. God, is it good. Huge fan, dude. The quick go-tos to plant them and then sending it. Oh my lord, is it nice? That's actually so neat. I'm very happy that that worked. It's probably about 2 seconds faster than the old one. Which, granted, is not much. But is pretty cool still. It's pretty cool still. So I'm very happy about it. I'm very happy about it. I think we can make it a little bit more efficient still. Because it does do. We need to. Something happens down here. Obviously, our print statements are slowing him down a little because he does a flip each time. But we're maybe our if not temp chord, we should just be processing him above or something. I don't know, maybe it's the print statements that are screwing me up. So let's just remove our print statements for right now. Let's see how much faster this runs without those. Because there should be nothing stopping this now. So we go through. Brilliant, brilliant, brilliant. We jump back to each position. I don't know why you scanned that much, my guy. Why did you scan that much? Something was still a little off there. Yeah, why is it getting up into here and then doing a bunch of things? Something is wrong with down here, the harvesting component. Temp chord should end up being empty at some point. So then chord list. You still make it into the harvest at some point, but why? How does this end up? Did we run out of pumpkin seeds? This is the. You should never reset drone or harvest grid. Temp chord dot append chord. Temp chord gets set back to 0. Chord list. I'm missing something here. Keep planting for a sec. Maybe we can catch it in real time. That's the first pass through. Now we're into you're getting position of coordinates, but you shouldn't. Why did you even have a coordinate in there? You harvest, okay. So now you're planting normally. Got really unlucky with that plant. A lot of dead ones on that one. Okay. Now you're going to do all of the spots that needed. Okay. Now we get into where you should be going directly to the places that you need to go, which comes into our function over there. You can see it passing through every single block of code that exists. If I click through, this is ungodly slow. Okay, you fill in that spot, you fill in that spot, you fill in that spot. There was something that went wrong right there. I'm gonna pretend that I didn't see it. One of you will tell me what's wrong with this in the comments. So now you're entirely filled out, but you went back through this again, and then you harvest. I mean, it's still like fine, man. It's still fine. It is a little bit more efficient than before, but I expected it to look better. Like your scanning is still, it's just a little jank. It's just a little jank. And I have no clue why in the world you did like a full scan reset there. I've got all kinds of issues in my code, man. I was watering a bunch of tiles. Like, how the hell did you get up here, man? It should never do that. Somebody will tell me how to fix this in the comment section. I'm pretty pleased with it for right now, though. I did what I sought out to do. It's a little messy, but I did what I sought out to do. It's gonna do it for this one. Thanks so much for watching. Can't wait to read the comments on this one. I'll see you tomorrow. Bye.